In this video, we are going to look at a couple examples where you can see how to factor out a greatest common factor from a polynomial and then use that GCF term to reduce your polynomial. Okay, so first of all, when we're looking at factoring out a greatest common factor, we're essentially looking at doing what's called reversing your distributive function. So if you look at this equation here, notice my distributive piece is on the right-hand side. My non-distributed polynomial is on the left-hand side. And what this is showing you is that in each piece of the polynomial, you have the same term, which is this a term. And so instead of distributing the a into your polynomial, you are pulling it out. And so we're putting the GCF on the outer side and leaving the polynomial on the inside. Okay, so what this is essentially telling you is that this a term right here would be your greatest common factor. Okay, so we're going to use that idea in these examples to be able to see, pull out that greatest common factor and write your polynomial in its factored form. To do that, I'm going to show you how to use prime factorization to identify your greatest common factor. So here I have 16y to the fourth. So my 16 can be broken down into 8 times 2. 8 can become 2 times 4, which becomes 2 times 2. So I've reduced it all the way down to its prime factors. And then I have a y to the fourth and a y squared. So when I look at y to the fourth, this can become y squared times y squared. And then I have my 12y squared. So here my 12 can become 4 times 3, which can reduce to 2 times 2. And then y squared will be left alone. Now the reason why I'm leaving it alone is because if you notice, I have a y squared in my first term and I've got a y squared in my other term. That is the greatest variable that is put together. And now we need to look at my greatest numbers. So notice under my 16 I have 1, 2, 3, 4 2's. Under my 12 I only have 2 of them. So 2 of them is going to be my greatest common factor, which means here that GCF is going to be 2 times y squared, which is the same as 4y squared. So what we have to do now that you've identified your GCF is we have to pull it out. So we're going to pull out 4y squared, and we have to look at what's left behind. So essentially this is my 16y to the fourth. I'm dividing out that 4y squared. And then I have my 12y squared, and again I'm dividing out the 4y squared. That is what happens, or that's how you get this a term out here. So if we look at that, my 4y squared is on the outside. I have a 4y squared left on the inside, plus a 3y, plus 3. Now here's a trick. If you don't want to remember the division piece, come back in here to your prime factorization. One of the things that you will notice is that I still have factors left over. So if you look at what's inside my parentheses here, my first term is 4y squared. So if you look at what's left over, I have 2 times y squared, 4y squared. If you look at my second factor, the only thing left over was the 3. Notice the 3 is my remaining factor. So the two ways or methods you can use is, one, you can think of it in terms of division if that's what works best for you, or think of it in terms of your prime factorizations. My circles here are what goes as part of my GCF. My orange squares are what makes up the remaining factors. Okay. Now I've got more examples that we're going to look at just to try and help make it a little clearer. Okay, so let's look at this next one. So here I have 9m squared minus 36m minus 9. Notice my last term here does not have a variable. Therefore, the only thing that can be factored is my numbers. So my 9 is going to break down into 3 and 3. My 36 will break down into 4 times 9. The 4 breaks down into 2 and 2. My 9 becomes 3 and 3. And then, of course, again, I have my 9, which becomes 3 and 3. So if we're looking at all of this, one of the things that you can notice is that I have a 9, I have a 9, I have a 9. Okay. And so because of that, what that actually tells you is that your greatest common factor here is going to be a 9. Now with this, we need to pull it out, so we have to be able to identify what's left over, and in this case what's going to be left over is my 4. And so here we're going to have 9 on the outside. If we look at my first term, the 9 pulls out. The only thing left is the m squared. If we look at my second term, I have a 4 left over and the m. And then if you look at the back term, I pull the 9 out, so it's a 1. Okay. Alright, let's go again. So let's start here with this first term. Now, the first thing I want you to notice is that we have this crazy negative out in front. Because you have that crazy negative out in front, you want to take note that you always want to factor out the negative from the first term. Okay? So one of the things that we always want to do, or that we should be doing when you're factoring, is you always want to pull that negative out of your first term in order to reduce your factor down. So we have to remember that we are going to factor out that -1 as part of your GCF. Now with that, I'm going to look at 56 x to the 4th y to the 8th. My 56 I can reduce down. This is going to be 8 times 7. The 8 is going to become 2 times 4. 4 becomes 2 times 2. Now I have x to the 4th. So here I know x to the 4th can become x and x cubed. My x cubed can become x squared and x. And I know my x squareds can become x and x. And then the last one that I have is I have y to the 8th. And so here I've got that this can become y times y to the 7th. And a y to the 7th can become y times y to the 6th. I know y to the 6th can become, say, y squared and y to the 4th, and so on and so forth. Okay, so you just kind of have to factor them down until you don't think you need to go any further. Now the next number I have to look at is I have this 98. I have x cubed y to the 4th. So my 98 here, I need to break it down. So my 98 can become 14 and 7. 14 is then going to become 2 and 7. My x cubed can become x and x squared. And my y to the 4th, if you notice, I have a y to the 4th right here, a y to the 4th here. So at the moment, it's looking like that's going to be my lowest term. Now the very last one that I need to look at is 35 x squared y to the 6th. So my 35 is going to break down into 5 times 7. My x squared can become x and x. And my y to the 6th can become y times y to the 5th. It'd help if I wrote it in the right spot, y to the 5th. And then y to the 5th can become y to the 4th and y. And if you notice here, like we just said, I have a y to the 4th, I have a y to the 4th, I have a y to the 4th. So I know that that is part of my greatest common factor. If I look at my x's, notice here I have x and x squared. So here is one of my lowest terms. Down here I have an x squared, and in my third term I have an x squared. And now with that I need to look at my numbers. So here I have a 5 and a 7. If I look, I have 2, 2, 2, and 7. And here I have 2, 7, 7. So I have a 7 that is shared on all three. So in this case, my greatest common factor is going to be 7 times the x squared times y to the 4th. Okay, and so that is my greatest common factor. Now the other thing I have to remember is we wanted to pull out that negative. Okay, so once we pull out the negative, we need to remember that your greatest common factor is going to include the negative out in front. Now with that, you also need to recognize what got left behind. So if we look down here at 35, my 5 is left behind, and then I have a y and a y. If I look at 56, notice I've got 2, 2, 2 left behind. I then have an x and an x. If we look at my 98, notice here I took the x squared. I have an x left behind. I've got a 2 and a 7, and then my y's are gone. Okay, so we have to kind of put all of that together. So if we look in terms of our factored solution, so we're pulling out the negative 7x squared y to the 4th. In my first term, again, 2 times 2 times 2 leaves me with an 8. And then I have x squared. Sorry, I forgot my y's. I have a y, and a y squared. So here this would then be a y to the 4th. And then if you look, because I pulled out my negative, notice this term is now positive. So when I go to my sign, notice my sign now becomes positive. Here I have 2 times 7, which is going to give me a 14. And then I have an x left over. And then notice here my sign is going to change. It's now going to become a negative. If we look down here, I'm going to have a 5. And then all I have is a y squared. So this is y squared, and that is what's remaining. So here we have our factored GCF and our factored polynomial. Alright, let's go ahead and do it again. So here I've got 27, I have an x squared, an x, and nothing. So again, the only thing I'm looking at are the numbers. So if I look at my 27, notice 27 can become 3 times 9. 9 becomes a 3 and a 3. Then I have 20. So 20 can become 5 times 4, which factors to 2 and 2. And then I have a 12. So here this can become a 3 and a 4, which factors to 2 and 2. So when I'm looking at these again, we are looking for a greatest common factor. Well, if you look, I have 3, 3, 3, 5, 2, 2, 3, 2, 2. So since there are no factors common to all 3 terms, the polynomial is not factorable. Okay, so essentially what this means is that you have no greatest common factor. Okay, so sometimes you will come across terms where you have no greatest common factor, and that's just it. There's nothing else you can do about it. Alright, last but not least, we can start with the first term, 15m cubed n. My 15 breaks down into 5 and 3. My m cubed can become m times m squared. I then have my m squared, which becomes m and m. Then I can look at my 24, m squared, n cubed. 24 can break down into 12 and 2, which can break down into 2 and 6. 6 breaks down into 2 and 3. My m squared becomes m and m. My n cubed becomes n and n squared, which becomes n and n. And then the last one that I have is 42 m to the 4th n squared. 42 can break down into 6 and 7. 6 breaks down to 2 and 3. M to the 4th can become m and m cubed, which can become m squared times m, which breaks to m and m. And then here n squared becomes n and n. Okay. So everything is broken down. So again, let's go through and let's look at what we have in common. In terms of numbers, I have 5 and 3. This is my lowest, so I want to look and see, and I have a 3 that shows up in all 3 places. So in terms of my numbers, that leaves behind a 5, that also leaves behind the 2, and the 2, and leaves behind here a 2 and a 7. Let's look at my m's. So I have 1, 2, 3 of them. Here I have 2 of them. Here I have 4 of them. So what's in common is 2 of them. So 1, 2, and 1, 2. If I look at what's left behind, it means there's 1 m left behind here, none of them here. I have 1 and 2 left behind over here. And then if I look at my n's, here I have only 1. So then I take 1 from my second term and 1 from my third. This is going to leave behind an n and an n and an n. Now that you've identified everything, we have that my greatest common factor is going to be 3 times m times m times n. So this is actually 3m squared n. With that, I can pull it out and I have everything left behind. So here this is 3m squared n. In my first term, what's left behind is a 5m. So 5m comes first. My sign here is positive. In my second term, I have 2, 4, 6. I have 2 times 2, which is 4, times 2 more, which is 8. My m's are gone, but I have 2 n's. So this is 8n squared. My sign here is negative. If I look at my third, I have 2 times 7, which is 14. I have 2 m's, so m squared and an n. And that is the reduced polynomial. Alright, so I hope that This video helped along the lines of being able to factor using the greatest common factor. So if you have any questions, please let me know. Otherwise, I do hope you enjoyed this video, and I'll see you next time.